right, guys. Today we are going to be talking about quadratic graphs. We dealt with linear graphs, and if you remember, linear was y is equal to mx plus c. It was linear because it was a line, right, with the same gradient everywhere. But this one is quadratic. Why? Because it is ax squared plus bx plus c. So we are going to be exploring this guy here. But then, now before you add bx and c, this is what you start with. And it's always written as y is equal to ax, right? But then here, it's our a here. If there is nothing there, so that means our a is 1, right? If there is nothing, that means our a is 1. So here, we just say a is equal to x squared. This is called a parent function. And function can be written as that. And this is equal to y. So we are going to talk about that. So that's why I'm saying y is equal to x squared. So it is a function, all right? So now, let's plot this parent function. I thought I would start with this because it is very important. It's a parent function. Everything that we are going to add after starts from there. All right, so I just changed a bit. What I gave you had 2 and 4, but then seeing the space that I have, I just changed to 1 and 2. So you guys will have like 16 and 4 and 16. But then I just changed it so that at least I'll accommodate, the space that I have. And I'm sure you guys would have had your x and y and tried to substitute, and you'd have gotten values like that, right? So now, if you have minus 1 and 1, where is minus 1 and 1? Let's plot now. You've got 0 and 0. There is 0 and 0 there. Minus 1 and 1, there is minus 1 and 1 there, because you start with x minus 1 and y, so that is the coordinate, right? And then minus 2 and 2, so minus 2 and 2, minus 2 and 4, sorry. Minus 2 and 4 is somewhere there. Now, listen to what I'm going to do now. Listen to what I'm going to do. Okay, so now I've drawn and I put that there. So you see this line is on the other half. And I know also I've got 1, I've got 1. And I've got 4, I've got 4, right? So that means the line that I have there acts as my axis of symmetry. Because here as well, I'll have what? I'll have my 1 and 1 and my 2 and 4. So you can draw this and say, from there I went 1, so I'm going to go 1 there, right? From there I went 2, so I'm going to go 2 there. So, but we're going to talk more about that. But what I wanted you to have at the end of the day is a beautiful function just like that. And we said y is equal to x squared, right? So that is my function. That is a parent function. So this can either move this way, down, and up. But you just have to understand that this is a parent function. So now for this one, if this is like this, so how is this one going to be like? So this one will be minus 0 and 0, 0 and 0 is there, right? Minus 1 and minus 1. So there is our minus 1 there. So minus 1 and minus 1 is there. So minus 1, minus 2, minus 3, minus 4. So minus 2 and minus 4 is something like that. So we are going to have a graph just like that, okay? So do you see that this one is smiley, right? Smiley. Don't know if the right spelling there, but this is smiley, right? And this one is sad. As we said that whatever we have here on this half, we can do it. We don't even need to plot it because we say 1 there, that will be 1 there. And then from there to there, as much as there to there is 2, from there to there is 2, so then from there to there is 2, so you can just plot like that. And you will see that I'm correct because what you have here is the same as what you have there. So this side, so that means this line acts as a line of symmetry. All right? So that's what you have. So that's y is equal to ax negative x squared. All right. Okay? So this is a sad graph. So that means every time you see a graph like this, it is sad. So that means it's going to have a maximum point. This is a maximum point because the graph, as it tends, in all these points here, the highest point is that one. So that is going to be our maximum point, and that maximum point is going to be your turning point. It's called a turning point or a vertex, right? Or a turning point. If this is a maximum point, so what will this one be? That will be a minimum point, and also is what? Is a turning point. It's also called a turning point, or you can call it a vertex. All right? Okay. Let's answer those questions there. What is the axis of symmetry of the line you plotted? So I just mentioned the axis of symmetry is a line that separates or that cuts a shape into two parts. So that means here, this is my axis of symmetry. And what is that line called? This is called x is equal to 0, or the y-axis. The y-axis, so that means the y-axis here is what? Is the axis of symmetry. And as well here, the y-axis is the axis of symmetry. Why? Because it divides this graph into two parts, equal parts. And then the second one is, what would you think the turning point is? So here, the turning point, I'll say TP or vertex. What is that point there? 0, 0. And what is that point as well? 0, 0. So that means our turning point is 0, 0. Turning point or vertex, that's where the graph turns. So it's going up, it's going up, it's going up, and it turns. So that is called the turning point. It's going down, it's going down, it's going down, and it turns, it goes up again. That's the turning point. And the axis of symmetry, that's the line that divides the graph into two parts. So I'm sure here you did understand, but there is one part. Here we said y is equal to ax squared. Look at my a there at that point. Look at my a. My a is what? My a is negative. So if my a is negative, my graph will face down. And look at my a there. There's just 1, right? So it's a positive 1. So if my a is positive, so my graph looks up. So we are going to talk more about that. So you know now, if I get it, y is equal to, if it's a positive there, it's looking up. If it's negative there, it's looking down, right? So sad and smiley. And on the next graph, that's where I'm going to be starting really talking about how do we how do we plot a graph that will have a bx and a c, or a bx only without a c, and I'll be talking about each component as we go. All right? Good.